All right, let's see if we can do a little. I'm not really a huge fan of the phrase by trial and error here. So this is 2.4, number 22. I'd prefer um, through
Guess and
a
check.
what's that? Guess and check. Through an intuitive method.
You can just say educated guess, Joe.
Yeah, an educated guess is fine. I would, by the seat of your pants, do this. Okay, so let's try some stuff. I want a matrix that squares to the negative identity matrix.
Okay, this one doesn't make sense to me at all.
Cool. That's probably totally fair. So all right. Uh, I guess I'm gonna start thinking, right? So what are you gonna start with?
The negative identity matrix.
Yep.
Good. That seems like a really solid guess. Okay, if I square the negative identity matrix, let me do this again. This is not my favorite matrix multiplier, by the way, but I don't want to. I'm gonna teach you guys to write some Python code to do this better, but for right now, we can use it. Oh shit! Is that a huge surprise?
No, that's why I'm confused, because you can't square a negative number and get a negative number.
Okay, so do we all believe that the identity matrix wouldn't work here either?
Yes.
Okay. So I'm gonna try something a little weird. If the identity matrix didn't work and the negative identity matrix didn't work, what if I just mix and match them? You guys see that?
Mm-hmm.
Do I have any hope that this is gonna work?
I think so, actually.
Crap.
Wait, but
Okay.
even
So this one squared to the identity squared to the identity. Uh, this one squared to the identity. I'm finding a lot of square roots of 1 here, right? You guys seeing that? That's the only thing that makes me think that this might have a chance in hell of working. It's because, like, if this was really just squaring, right? Like, if this was just along the lines of numbers, there would be 1 and -1. The fact that I found this other one with the kind of mix and match diagonal makes me think there might be a chance for this. You guys with me? Okay, let me try a slightly different mix and match. So on that one, I mix and match the minus signs, right? What if I just mix and match the positions? So I'm going to put a 1 here and a 1 there. I'm just going to do 1s on the anti-diagonals. Do I think this is going to work?
No.
Probably not. My expectation is that I'm going to even get this thing back, right? Oh, weird. Sorry, that's probably a little small for you guys, isn't it? That might be a little better. Okay, so I just found that if I do, oops, not there. If I do this one and square it, I get the identity matrix again.
I think we need a negative.
Yeah, there better be a negative in there, right? Like, I didn't think that was going to work just because it didn't even have a negative number in it, right? So do you want to make them both negative or just one of them?
Just one.
Why not both?
Because if they're both, they're definitely gonna cancel out.
Yeah, it feels like if they're both negative, they're both going to hit each other, and yeah, exactly.
You're a genius.
No, I'm not. We took a bunch of tries. But we started with like this is how you do this crap. Like it takes a bit. You try some stuff. It's way handier if you use a calculator when you're guessing checking, or when you're trial and error or whatever the helling. When you're educated guessing, use a calculator. All right. So
I don't know why my first intuition is to always go to a 3x3 matrix, but it's killing me every time.
yeah, don't. Your first intuition should be go to a 1x1 matrix.
Yeah, I don't-
Those aren't usually very interesting.
I don't know why I keep going to a 3x3. It's like the first thing I write down every time.
Yeah, if you find yourself in the place that you're guessing 3x3 matrices, please save yourself some time and effort. Use a calculator.
Yeah.
All right, so we managed to guess one eventually. Oh snap! This is important. So b times c is 0. I just need two matrices that I can multiply together and get 0. That feels wrong. You guys with me? Why does this feel wrong?
Because it says non-zero.
Well, it doesn't actually. Oh, it does say non-zero.
I was just
Okay.
gonna say I didn't see a non-zero, so I was gonna say just set like B or C to 0.
Yeah, just set b or c to the 0 matrix. That's certainly true, right? B times the 0 matrix is the 0 matrix. But this feels weird, right? Because this means that there's. So if I can actually do this, this means there's no 0 product rule for matrices. You guys see that? I don't know how I need to decorate that, but I'm decorate this in a way appropriately that it goes deeply into your brain. Because you will make this mistake at least once, I guarantee it. Not because you're dumb or anything, just because everybody does. It's really easy because we taught you, like, you all are good with numbers. At this point, you are good with numbers. The problem is that your intuition for numbers doesn't really work for matrices because they're functions. You guys with me on that? So if I need to guess and check a couple matrices that I can multiply together to get 0, I might start with the identity. If I multiply the identity by a matrix, what am I going to get?
Itself.
The one you started with. That's a bad. Okay, so that's a crap idea here, right? Okay, have I seen a matrix that reduces things in size? Like, I want two matrices so that when I multiply them together, I get nothing left, right? So have I seen a matrix that can reduce things in size?
Permutation matrix.
Yeah, the permutation matrices kind of rearrange things. They don't make them smaller, though. Remember just a minute ago I had a way to forget the y coordinate?
Yeah, I was thinking that, but I can't remember the name of it all of a sudden.
Yeah, those are projection matrices.
Thank you.
So I'm gonna kind of think to myself projection, right? So I'm gonna think about this guy times. I need to fill in C. Okay, so this one zeroes out the y coordinate, right? If you want to zero out both coordinates,
Then just have a projection matrix that flattens out the x's instead of the y's.
okay, so how do I write that?
I'm thinking, let's see, maybe a 0, 0. I mean, it could be a one there or a one in the other spot.
Okay, so if I put a 1 here, it's going to take the x coordinate and put it into the y spot.
Oh yeah,
So that's the permutation that
Gotcha.
Cody was working with. And the thing is that both of those would work. So this one permutes x into the y spot and sets the x spot to 0. You guys see that? It's doing kind of two things at once. I'd be more like, personally, I probably would have put my 1 over here and put a 0 here and done. I'm going to project onto the x in one kind of thought and project onto the y in the other.
yeah. That's
Kind
personally
of
what
with me
I
on
would
that.
have done too, but I was thinking, it could work there theoretically.
And it would. Like, I'm gonna dump that here, but it would work. I'm gonna do this because I think it's pretty intuitive, unlike my pen's design, where I keep clicking a button. So this one zeroes out the x coordinate. Right, so this one's projecting onto the x-axis, and then this one's projecting onto the y-axis. So if you take 2-dimensional space, right, and you first do, let's see, first is this one, right? So we're projecting this way. Why is that one first? Where do I put a vector to do this stuff to? If
That's
you're
a
gonna-
fantastic dance.
I'm trying. I don't have any juggling balls, otherwise I'd juggle.
If I had my camera, I'd juggle with you. On the right.
Good. You put vectors on the right, right? You do f of x. So we're pantomiming that, right? So we do ax to take the function a and apply it to the vector x. So here I'm thinking, all right, so if I put an xy here, right? First we're gonna do this part. That's gonna zero out the x coordinate. That's smashing everything onto the y-axis. Then this next bit is going to take the result of that, right? So we've already smashed, right? So now these are things that look like 0 and y. And then we're going to do this to them. Well, this zeroes out the y coordinate, and they already have 0 in the x. That's really projecting this line onto the x-axis, and the image of that is just the 0 vector. You guys see that?
Yep.
This is why I don't really like to call this trial and error, because that wasn't really trial and error, right? That was like, okay, I have a plan. I'm not sure it's going to work, but I'm going to try it. I guess that amounts to trial and error. I don't know. Put some wisdom of Yoda's in here. Oh, that one seems weird. Do we have time for that? I want to do 23, so I'm going to let you guys do this last part here. Is that okay? 23 is just an expansion of part of this. And I'm gonna do part A, and then I'm gonna offer you a piece of advice for part B. Is that okay? Cool. Good talk. This is actually nice. When you guys have all your mics muted, you can't raise objections very fast. All right. So the piece of advice I have for part B is that you're gonna need a 3x3 matrix here.
Hey, my intuition was right.
Okay. Now, and if you need a word to Google here, the word you want to Google is nilpotent. So a nilpotent matrix is a non-zero matrix that has a power that equals 0. So let's find our smallest available non-zero. Well, let's find our smallest available nilpotent matrix. Why can't it be 1 by 1? I missed a joke, huh? Figures.
Yeah, you did.
What was it?
You said you're gonna need a 3 by 3 matrix, and Jacob was like, "Oh, my intuition was right."
Oh, I didn't miss that. That was actually funny.
Oh,
All right, perfect. I need a why. Wait, why doesn't this work for a 1 by 1 matrix? What number A are you going to put in here so that A squared is the 0 1 by 1?
Well, if it's not 0, then nothing.
Shit. You mean there's the 0 product rule in one dimension? Crazy. Yeah. That ain't going to work. So I have to move to 2 by 2. Okay, so I need something so that when I square it, I get 0. This should feel a little bit like the question we just did where we took 2 matrices, multiplied them together, and got 0, right? So before I did this by projecting in 2 different directions. Got any intuition on how to accomplish this one?
Can it be -1, -1, 1, 1?
-1, -1, 1, 1?
1, yeah. And then we're gonna scale this, right? I think it's gonna come to a 0.
Oh, I don't know. Let's try it. I'm going to go get my little calculator out because I'm lazy. Let's see. So -1, -1, -1, -1, 1, 1. I'm saying this in a badly out of order. Oh, shit. Karen for the win. Nice redemption, dude. Perfect. What brought your intuition to that, if you don't mind?
Yeah, so like if we do like dot product and stuff, right? I was thinking about like that, like if the upper is gonna be negative and then the lower lines we can make it positive, right? And then when we're gonna dot product it, one's gonna be negative, one's gonna be positive, they're gonna cancel out, it's gonna be 0.
Nice. Yeah, you need the rows to be perpendicular to the columns, right? So you just
Yeah.
force it. That's right. Another way you could do this is you could take one of those matrices that we started using before. Remember we had one that forgot a coordinate and then swapped a position? I think that was this matrix that we had earlier. You guys see that? So this one takes the x coordinate, puts it in the y slot, and then forgets the y coordinate. So when I square this, I should get the 0 function, right? The 0 matrix. We can double check that with our calculator. Put 1s here and fill things with 0. Okay, cool. The reason I bring this one up and don't let Karen have his victory in entirety as he deserves is that this one might be a good one to think about for that part B. Finding one with a squared not 0 is a little weird. I think this will get you there if you think about it a little bit. Any questions on that?